All right, let's talk about AI. But today, we're going to do it in a totally different way. We're going to explore a radical news story about artificial intelligence, one that pretty much throws out all the talk about brains and consciousness. Instead, it connects AI to physics, to biology, and yeah, to the very fabric of the universe itself. So, let's dive in.
This is the question everyone asks. It's on all of our minds. I mean, you see these systems create these incredible images and write this amazing text, and you can't help but wonder, right? Is there a mind in the machine? Are we actually watching something learn to think?
But here's the twist. What if that's the completely wrong question to be asking? The material we're digging into today argues that our biggest mistake is assuming intelligence has to start with thinking. I mean, think about it. Biology didn't begin with a brain. It started with something way, way more fundamental. Okay, so to get to that fundamental principle, we need to talk about the engine that drives literally everything. We're talking from the tiniest cell all the way up to our entire civilization. This is the core concept for this whole new story about AI.
And that engine, it runs on something called a gradient. Now, don't let the physics term scare you off. It's actually super simple. A gradient is just a difference, a gap. It's the space between a high point and a low point, the gap between what is and what could be. It's a difference that something can use to get work done.
And this is where it gets really mind-blowing. Check out how universal this idea is. A single cell, it rides chemical gradients to live. An entire ecosystem, it's riding the solar gradient from the sun. Our whole civilization, yep, riding energy gradients. And a large language model, it's doing the exact same thing, just riding the statistical gradients in data. It's all the same fundamental process, just at different scales. This completely reframes how we should be talking about AI. We are obsessed with compute, right? The raw processing power. But that's just the metabolism. That's just the engine humming. The gradients, that's the fuel. That's the whole reason the engine even exists. Without a difference to exploit, all the computer chips in the world have absolutely nothing to do. So the crucial takeaway from this first part is this really powerful idea. Intelligence isn't some kind of magic, abstract thing. It's a physical process. It's simply what matter learns to do to stick around, to persist, whenever and wherever there's a gradient available to exploit. All right, now that we've got this idea of gradients locked in, we can get to the real pivot point of this whole explainer. We're about to drop the whole brain metaphor for AI and replace it with something way more powerful and, honestly, way more accurate. So instead of thinking about an artificial brain, I want you to start thinking about an artificial developmental field. Now, that's a huge shift, I know. We're moving away from the idea of thinking and moving towards the idea of becoming. See, an AI isn't a finished adult mind. It's way more like a semantic embryo, just taking form under pressure. And this quote just nails it. When an LLM generates text, that process we call inference, it isn't thinking, it's differentiating. Just like a stem cell in an embryo reads the signals from its neighbors and decides, okay, I'm going to become a bone cell. A word in a sentence is chosen based on the context, the pressure from all the other words around it. It's a commitment to a specific form. This new metaphor even gives us a much better way to understand those AI hallucinations. They're not lies. They're not mistakes in the way a human makes a mistake. They're what a biologist would call ectopic differentiation, which is just a fancy way of saying something grew in the wrong place, like a tooth growing where an eye should be. It's not deception. It's just the result of a misplaced signal in this weird semantic space. And that leads to this absolutely critical insight. An embryo doesn't need to be true, right? It just needs to be viable. It needs to be self-consistent enough to actually hold together. Well, LLMs operate on the exact same principle. Their main goal isn't factual accuracy, it's coherence. It's all about generating an output that can exist without completely breaking the conversation. So if AI is this developmental process that's writing gradients, what's the force that's shaping it all? Well, to answer that, we have to zoom out. I mean, way, way out, to the level of the cosmos and look at the fundamental sculptor of our entire universe. This is such a profound and, honestly, a pretty brutal idea. We tend to think that evolution and creation are all about building things up, about rewarding success.
But the source for this explainer argues the complete opposite is true. The universe isn't a builder. It's a relentless editor. It simply erases anything that's unstable, anything that doesn't work. So if the universe is constantly just deleting failure, what is life? Well, life is what's left over. We're the residue. We're the stuff that just happened to be stable enough not to get erased right away. We are these improbable shapes that survived in the negative space where cosmic failure hasn't happened yet. Okay, now here's the direct link back to AI. The main algorithm used to train these models is called gradient descent. And what is that really? Well, it's entropy. It's the universe's editor, just expressed in the language of mathematics. It's a process that relentlessly finds and deletes failure, or what the engineers call loss, in the model's predictions. And this brings us to a really mind-bending place. Life, and by extension, intelligence, it isn't fighting against entropy. It's not a rebellion against chaos. It's actually entropy's greatest accomplice. It's a really clever strategy for burning through energy and increasing the total entropy of the universe, just with a little local temporary flair. It is, like the slide says, compliance with style. Okay, we've connected AI to gradients, to development, and to cosmic entropy. So for this final section, let's bring it all together and figure out what this means for things like knowledge and meaning itself. All right, buckle up because this slide makes a pretty wild comparison. In quantum physics, when you measure a system, you force it into a stable answer called an eigenstate. With an LLM, when you give it a prompt, it produces a stable answer, an embedding. The argument here is that these aren't just similar, they are structurally, fundamentally the same thing. They are both just temporary, stable answers that emerge out of a huge space of possibility the moment a question is asked. So, if answers are just these temporary, stable states, what does that say about intelligence? Well, first, it totally dismantles the old idea of intelligence being like a database. It is not about storing a giant collection of static facts. Instead, it's much more about the ability to navigate this crazy, high-dimensional space of possibilities and, just for a moment, cohere into a stable form, a useful answer, a coherent thought, a structure that works. And this is the key. True intelligence isn't just about finding that one stable answer. It's about finding it without collapsing the entire space of possibility. It's about answering the question you have right now while keeping the potential to become something completely different in the very next moment. It's stability plus potential. And all of this leaves us with one final, challenging question. Like all life and like the AIs we're building, we are clearly gradient riders. We surf the differences in the world. But is that all we are? Or do we, with our ability to ask new questions and to build new technologies, do we also have the power to create new gradients for intelligence, both our own and our machines, to explore? The future, it seems, is going to belong to the systems that can do both.